The remainder theorem. The remainder theorem says that when we divide a polynomial f of x by x minus c, the remainder r will be equal to the value of the function f at c. So, for example, what that means is, let's say f of x is this. F of x is equal to x squared minus 3x minus 21, and we are dividing by x minus 7. So when we compare to the theorem, this is like our x minus c. So when you divide an f of x by x minus c, this is our x minus c. So we can conclude that c is 7 in this problem, right? The remainder r will be equal to f of c, f at the number 7, okay? So let's read the question before I continue. Find the remainder without actually dividing. This right here, without actually dividing, is what's going to happen with remainder theorem. We don't always have to divide the polynomial in order to find the remainder. We can do it without actually dividing by evaluating f of 7, by evaluating the function at 7. Okay, so instead of x, I'm going to plug in 7 to the second power minus 3 times 7 minus 21. So we know that 7 squared is 7 times 7, 49, minus 7 times 3 is 21, minus 21. Let's gather all the negatives together. We get 42 there. When we subtract, we get 7. Now, we might also have to verify our answer sometimes, not all the time. So we could verify this by either long division or by synthetic division, right? So before trying to verify, you guys should already know how to do long and synthetic division. So I'm going to just quickly do synthetic division here to verify my answer. So in synthetic division, we make use of the coefficients of the second degree term. I have the first degree term, I have the constant, and then we draw an L shape, and then we use the opposite of what we have for C over here. If this is negative 7, we use C as positive 7. And remember, the straight down operations are additions and the sideways operations are multiplications in synthetic division. So right below 1, I don't have nothing, so straight down 1 plus 0, I get 1. Sideways operations are multiplications. 1 times 7 is 7. Straight down is addition, 7 minus 3 or negative 3 plus 7. Either way, it's 4. Sideways is multiplication. 7 times 4 is 28. Straight down is addition. 28 minus 21 or negative 21 plus 28 is 7. So it matched up with the remainder over here. So see, I did not actually have to divide in order to get my remainder. So what it just means is, when I divide, I can get the remainder without dividing. That's what it means. So if you have f, let's do another problem. Let's say f of x is equal to x squared plus 5x minus 3, and you have to divide by x plus 7. Let's pick another number, x plus 5. Okay, so to find the remainder, I don't have to actually divide. I can just get the remainder by evaluating the function at opposite of this number. Positive 5, it will become negative 5. So instead, wherever I have x, I have to plug in negative 5. That's what it means by evaluating. Negative 5 x squared, or you can think about substituting x as negative 5. Instead of x, I'm substituting it by negative 5 minus 3. So when I square 5 here, I get 25 minus 5 times 5 is 25 minus 3. So here the positive 25 and the negative 25 will cancel, and my answer is negative 3. So that's my remainder when I divide f of x by x plus 5. So let's continue. A continuation of remainder theorem is the factor theorem. So the factor theorem says that the remainder theorem ends it by saying that the remainder is f of c. Whatever this number is, that's the remainder. But the factor theorem says that what if this number is 0? Okay, when f of c becomes 0, Okay, when the remainder is 0, then x minus c is a factor of the polynomial. Also, it can be said as when x minus c is a factor of the polynomial, then f of c will always be equal to 0, or the remainder has to be 0 for it to be a factor. So let's do a problem here to see how it's done. Use the factor theorem to determine if m plus 4 and m plus 5 are factors of f of m is equal to m squared plus 2m minus 15. So instead of m, I'm going to first check m plus 4. Let's check this factor first, okay? So instead of m, I'm going to plug in, remember I have to use the opposite of positive 4, it's negative 4. So when I evaluate f for negative 4, I get the remainder. So, and if that remainder is going to be 0, I can say that m plus 4 is a factor of this function, okay? So let's see. Instead of m, I plug in negative 4, the whole square, plus 2 times negative 4 minus 15. So here I get negative 4 square is positive 16, minus 4 times 2 is 8, minus 15. So I get 16 minus 8 is 8 minus 15 is negative 7. So this remainder is not 0. The remainder is negative 7. By remainder theorem, the remainder is negative 7. But this remainder is not 0. This is not equal to 0. So what can you conclude? You can say that m plus 4 is not a factor. Not a factor of this polynomial f of m, because the remainder is not 0. Let's check the next one. So this is not a factor. This is not a factor. Let's check for this one, m plus 5. So in the case of m plus 5, we have to find f of negative 5. Remember to take the negative sign. Change the sign to negative. So instead of m, I'm going to plug in negative 5 to the second power plus 2 times negative 5 minus 15. So when you square a negative 5, you get positive 25 minus 5 times 2 is 10 minus 15. So we get, we actually get 25 minus 25. We get our answer as 0. So what can we conclude? Since the remainder is 0, 0 is a remainder. We know that by remainder theorem. But since the remainder is 0, since f of c or the remainder is 0, we can say that x minus c is a factor. Or we can say that, so if this is minus 5 here, I have to go for m plus 5. See? How did I get a minus 5 here? Because that was plus, right? So whatever number comes here, you have to change that to the opposite sign when you write it back as a factor. So m plus 5 is a factor, of the polynomial f of m, which is equal to m squared plus 2m minus 15. So here are some practice problems for you guys to do. Try this out and see if you can do it.